Well, hello class, it's Mr. Thomas. Hope you're doing good. Today we're going to learn about the nitrogen cycle. So on your next new page, go ahead and write nitrogen cycle. Also, make sure you take good notes because we will have a test over this cycle. And also, I'd like you to leave both of your facing pages for this diagram. So I've got one page, and try to coordinate your notebook so you have the facing page also included. If you need to skip a page to make this happen, go ahead and do so. But I'd like you to write down as your title, nitrogen cycle. And the first thing that we're going to write is the air we breathe right now is 79% nitrogen, also known as N2. Okay, that's atmospheric nitrogen. And it looks like this. Okay, this is a chemical model, and that's what we call atmospheric nitrogen. Okay, so go ahead and jot that down. Atmospheric nitrogen. So the water cycle is important, the carbon cycle is important, but the nitrogen cycle is also important. In fact, 79% of the air we breathe has nitrogen in it. I always thought, I was just breathing in oxygen when I was younger, but just oxygen is just one component of air, and nitrogen is the main component of air. So although the carbon cycle is important and the water cycle is important, the nitrogen cycle is just as important, and oftentimes we don't learn this cycle as well as the other cycles. So in this class, our next big test will deal with the nitrogen cycle. Okay, so as in all cycles, nitrogen has to get from the atmosphere to another, if it's in 79% of the air we breathe is nitrogen, how does it get into the soil? Well, just go ahead and draw a little cloud. Okay, this is a diagram, so we're going to draw a lot of pictures. I'm going to pretend I'm making a kind of a cartoonish cloud in the corner of my my notebook paper here, and I'm going to draw a lightning bolt. Okay, a lightning bolt coming out of the cloud. So just draw a little lightning bolt like that, and that's significant because nitrogen is fixed. Okay, our key word here so N2, when it gets struck by lightning, it is fixed into the soil. So we call that process fixation. So go ahead and write fixation. Okay, nitrogen is pulled out of the sky into the ground. Okay, so I'm gonna actually go ahead and draw a ground level here. Right in the middle of your page, just go ahead and draw a line showing that you've reached ground level. Okay, so that's what we call fixation. It'll actually drop from the sky. N2, nitrogen is a triple bond, so it's very stable bond. And then it is struck by lightning, and of course when lightning hits it, that bond is broken and it goes into the soil. Okay, and that nitrogen in the soil becomes a more usable form of nitrogen that we call nitrate. Okay, nitrate, NO3. Okay, so just go ahead and draw that. That's a different form of nitrogen that we call nitrate. Okay, and nitrate is very good for plants. So I'm going to actually just draw a tree here. You can feel free to draw whatever type of plant you wish. I'm going to draw a tree. And My trees got roots, of course. So I'll just draw some roots. It doesn't have to be really, really technical, but get the idea. There's roots below the ground for my tree. And that nitrate is assimilated back into, so I'm going to write assimilation. It's assimilated into the roots of the tree for nutrients, okay? So nitrogen fixed from the sky is really important for the soil, okay? Nitrogen can also be fixed other ways. On the sides of trees, occasionally you'll see this substance. It's I've got some here to show you. On bark, you'll see what's called lichen, okay? And lichen, we've talked about in class before, is also a fixer, okay? So I'm going to just write on the side of this tree, I've got lichen, L-I-C-H-E-N, and nitrogen can be fixed that way too. So N2 can be fixed through lichen, okay, that crusty stuff on trees, and that also can go into the soil, okay. Additionally, lichen is not the only fixer, and lightning is not the only fixer. We also have, I'm just going to draw something here as well. We've got, I'm going to go ahead and draw a plant here. And it's like let's just draw like a little soybean plant, because this is ag. We're going to learn a little bit about, and again, I'm just drawing a plant with leaves on it. Doesn't have to be perfect, but this is a type of a soybean is in a family of plants called legumes, okay? And I'm drawing the roots on purpose, okay? So go ahead and note, right, this is a soybean plant, and it's got legumes, okay? Legumes. Or actually, it is a legume. It's an example of a legume. So anything that has a pod, so soybeans have pods, peanuts would be legumes, green beans would be legumes because they have pods. A pod-bearing plant is known as a legume. And what it has in its roots, the key, and that's why I drew the roots, is something pretty amazing. So we're going to zoom in. I'm going to make a drawing here, like a zoom in drawing. So just draw like a little cone shape with a circle kind of signifying that we're magnifying this image. Okay. And our legumes, their roots, okay, have these pods on them, or most books refer to them as nodules. So go ahead and draw some roots with these big bumps on them. And inside these bumps, there exists, I'm going to draw some dots here, a symbiotic relationship. Bacteria live in these legume root nodules, and we're going to just go ahead and label those as nodules. And or I guess root nodules. And inside those root nodules, we've got bacteria that grow. So the bacteria live inside, and those are the little dots I drew. They're microscopic dots, and they reside in those nodules, and they also fix nitrogen from the sky. Okay, so I'm going back up here. My atmospheric nitrogen goes into, and specifically gets pulled into the roots of soybeans, okay? So, or any legume. And that nitrogen is then assimilated into the soil so that it can be uptaken into plants or into itself in the soil itself. So we have a mini cycle here, and that's due to fixation and assimilation. Okay, but the nitrogen cycle is much more expansive than that, actually. We get nitrogen too, or our livestock. So I'm going to draw a cow here, okay, or a pig, or what you can draw whatever you want, really. Okay, I'm going to just draw a cow. And again, if you want to draw a pig, or you could even draw a human being, it doesn't matter to me. But we get nitrogen from eating legumes, okay? And that's, or something that eats a legume, which we'll talk about in a moment. But so this is a really poorly drawn cow, but it's got a fairly long nose. I'll give him maybe some striping to make him like a Holstein cow, just maybe so he makes him look more like a cow, and give him udder. But anyway, we've got this cow here, and needs another leg, and the cow, of course, is able to get nitrogen as well, okay? And it gets nitrogen from consuming a legume, okay? So in this case, we've got our soybean, okay? Also, there's fixers like clover is a fixer, but it can take it in through consumption, okay? So consumption, okay, eating that legume that's got nitrogen in it allows it to take it into its body, okay? But of course, the nitrogen cycle being a cycle doesn't end there. And I'm going to end my little part one of this notes by putting the next phase of the nitrogen cycle here, which is this right here, okay? Yeah, right there. Okay, so that is where the nitrogen cycle goes next, okay? And what is that? Of course, that's a cow patty. It starts with an S, it ends with a T, it comes out of you, it comes out of me. I know what you're thinking, but it's not that. Let's be scientific and call it scat. Yep, that's right. Scat, okay? Scatology is the study of poop, okay? And manure gets into the ground as NH3, okay? And I'm gonna stop these notes for now so you guys can get caught up, because this is getting to be quite a complicated picture, but we gotta keep on going. So part two of the notes will go into what happens in the soil, but all you need to know right now is that nitrogen is fixed from the sky, atmospheric nitrogen, three ways. They all start with the letter L: lightning, lichen, and legumes. And then they get into the soil and go from there. All right, I'll talk to you in part two of these notes.